We're going to take another look at the base slider. We'll use this in geometry, which would be on the right plane. Extrude it out, and then to do the same thing, we'll introduce the tools for the advanced, and then also look at the threaded hole geometry. Let's go ahead and move that off to the side. And we'll open up a new metric part. And a sketch on the right plane. Alright, I've collapsed the command manager, right? So if it's not push pinned, it will collapse into the title bar. And so a center line, vertical, infinite length. We'll place that on the origin. And the advantage with the infinite length center line, again, is that we won't ever run out. Going into the line, I'm going to sketch the outside. Let's see the sketch inputs on, so 24. And it doesn't really pick up the center line, so the diametral or the half dimensions, diametral, radial, or the full or half. So we'll go ahead and put in the rest of the dimensions. So again, if we pick the object in the center line, or the center line the object, as long as we're between, we'll get the half dimension or the radial if it's a revolve. And on the other side, we'll get the full dimension or the diametral. So 60. And it's still in diametral because of the D. So all I have to do is pick the object. That'll be 20. And then I can escape. Once will put me back into linear, and twice will put it back into, well, we'll clear the tool. Alright, so 44. Select. If we go from right to left, we're going to pick everything, and when I mirror, I will get the entire object. If we just go into the mirror command, or go from left to right, then it will be asking us for the center line. So left to right, and pick the objects. Didn't see a preview, that was kind of weird, but still having some video issues. And once I pick the center line to mirror about, then that will generate the geometry. Let's see, for this one we can right click and extrude boss base, and the overall is 280. We'll go ahead and accept. Alright, so another advantage of the hole wizard is that as long as these two planes are on the same level, or I pick the higher of the two, I would be able to put that geometry in. So we'll go to Features and Hole Wizard, or on the S key, we'll look for the Hole Wizard icon. And we're going to put in the 5mm dowel pins. And really for this assembly, pressing those two, there's no compressive force for the geometry to hold it in place. So if there's vibration or anything going on, then it would probably work loose. Alright, so if you get the 3D sketch question, just pick the face. And we'll set our points. I'm just going to do the 2 points. And we'll go back to select. And if I select Control Select the 2 points, then I can do horizontal. And then one more for the dimension. And our dimension is 115. And enter. And 160 between the two holes. And enter. And then from the edge, we have the 5 millimeter. And enter. Okay. So if I go to line, we can switch to the construction or the center line for construction. In this case, we'll pick up the origin, or we could go midpoint to midpoint, looking for those relations. And this time I will select right to left so that it includes the center line. And let's see if on the right click, oh, I lost it. So if I'm on the line or on one of the points, I can right click and look at the sketch tools and mirror entities. And then we have that geometry. So that will be the dowel. And then here we could do the 10 millimeter through, but I want to introduce the Features Hole Wizard Advanced Hole, which would be the same as hitting the S key and going to the Advanced. Right, what this is going to give us the ability to do then is set this geometry. So if I wanted to maybe adjust the height or put in additional steps, then we can use the top face, rotate over and pick the far side face. And once I figured out the geometry, if we were doing something like a gas mixing, so if you think of acetylene torches where the oxygen and the acetylene have different size or different ports, but similar geometry, maybe even left-hand or right-hand threads, we could build that in to this advanced hole geometry, make it a favorite, and reuse it in several places. So on the top side, let's just put a near side countersink. And we are still in inch, so we'll switch over to metric. And the flathead screw for an M10. Right, and so 20 millimeters across the top, and diameter, oh, that's the depth. Okay, and then we're going to add, insert an element above, insert an element below. We'll do the through hole. And not a dowel, we'll just do the clearance for number 10. And a normal fit is 11. And we'll just tell it to go through all for now. All right, so kind of turns that one red with through all, so we need to maybe look at up to the next element. All right, so when it finds that geometry, then it will go back and pick it up. So from the far side then, if we stay with a countersink for instance, and that one's a little on the large side, and we'll probably run out. But for this example, it'll be fine. So socketed cap screw, and again we need to switch to metric, and we'll pick up the M10. And actually, if it was clearance where it would go through, maybe we'll do an M8. And 18 millimeters on the bottom for the 20 millimeters. I might want to reverse this. All right, so positions, very similar to the hole wizard. Going to place. No instances to skip, so we need to S key or pick your dimension. And that did not select, so I'm going to rotate over a little bit and make sure I can see what I'm picking. I don't think it... oh, I am in instances to skip, dimensions. So basically don't want to be in instances to skip when we start selecting. So let's escape out of that and make sure that that's clear. There we go, I see the blue dot now. So that was 20 millimeters in. And we'll pick. And it's not letting me grab the origin, so let's go to the top view. Okay, so in the top view you can see the origin, or I could possibly pick it from the flyaway. And then those will be horizontal. Alright, and then we'll see what it looks like. Alright, so it's going to be a little different. We might have the geometry to change or update, but just as an example of how you can do stack ups, and if we needed to add another, I could possibly go with, let's edit that that feature. If we needed another group on the bottom, we would just select and add, and we could do those additional items. All right, so that's not going to work real well with our pin, but you get the idea. All right, so the advantage of the whole wizard is going to be that if I decide I want to switch these over to an M5 by 0.8, for instance, I can edit, and we'll go into the tapped hole and pick for the M5 by 0.8, so relatively the same size. Depth, again, we want to be 10 millimeters. If we want 10 millimeters on the thread, as a general rule, would like to have 2 times the major diameter of the threads. Could be as little as 1 time. And then the spiral point tap, a standard tap, is probably going to have 4 to 5, maybe 3 to 5 threads for the lead, which times 0.8 is going to be about 4 millimeters. So would want to look at making the hole depth 15 millimeters for 10 millimeter. And the 12.4 is close, but as long as I'm not intersecting or going to break through when I don't want to, then it's going to still be good for the geometry. And then we're going to be able to see the cosmetic thread and the hole depth and know that we have plenty of clearance. All right, and then the final group, let's go into the face. For the always forget. For the thread, we need to either have the shaft diameter, and I prefer to cut, but if we wanted to extrude the thread, then we would need the minor diameter. So let's do an M12 by 1.75, and we'll draw the circle. And if I do 12 minus 1.75 for the minor diameter, so 10.25, and we'll go ahead and place our geometry. So 70 looks okay. Maybe 75. Okay, make sure that I'm selecting and go back and pick the origin and make that horizontal. And we accept it. Oh, I did not extrude it, so let's go back into the features and we're going to extrude cut. And we'll just do up to next or through all. Alright, so that gives us the shape, and I'm going to switch back to solid. That gives us our through geometry. Then when we go to the feature or the S key and go into the thread, this is going to generate a solid thread, a feature thread. So the cosmetic thread will suffice in 99% of the cases, and I already had the edge selected, so that's the start. And then the face where it is going to begin, and we'll usually offset that at least the pitch, so there's one full thread above. And then up to selection will be the bottom. Make sure that that's highlighted. And we'll offset it, also one full thread, so the pitch. And Control 1 will put us into the front plane. Take a look at this. Okay, so the bottom needs to reverse the offset so it's above. And then this is a metric tap. Here it found the M12 by 1.75, but if it hadn't, a lot of times it will go to the smallest, but we would scroll down through the list until we find the thread. And this is going to be a cut thread. So if we did the extrude thread, we would draw it at the 12 millimeter and then work on the trim with start face, trim with end face, because it would have to extend past, otherwise it's going to be an incomplete thread. So if we were 3D printing this or wanted it for visual effect from a machining standpoint, it's kind of a pain to work with. It doesn't really look like a hole. The CAM software doesn't see it as a hole, and generally it's not that great for us to machine to. All right, so if it was a left-handed thread or multiple starts, you could have 2, 3, or 4 leads, and that's just a matter of the geometry. So we'll go ahead and pick that. And when I zoom up on this after it finishes, it is going to take a few resources. You can kind of see that we have the circle and the minor diameter, but the lead makes it kind of elliptical in shape. And with all of that geometry, it also is going to make this a bigger file. So I would identify for the machining, I would identify which one of these will act as a center, verify it against the drawing or against the geometry. If it's a translated file, it makes it a little more difficult, but putting the minor diameter in place, at least a little bit bigger than the major diameter, and I would just make that a straight hole if I couldn't modify it otherwise or suppress it. All right, so let's go ahead and save this. And we'll name this the base slider, and give it a revision of R2. And we're going to rebuild and save the document so everything's updated. And then there's a couple of ways, since we've already created the assembly. We'll find our slider assembly. And let it open. Extend this out a little bit so I don't have to use the arrows to navigate between my tabs. So if I wanted to leave this slider, we would make a configuration. If we want to replace it, then I have to look down through here and find the replace. But this is kind of a permanent. Replacing the components means that we're removing the revision 1 and we're putting in its place revision 2. Since I want to leave that in, we're going to add a configuration, and my what if scenario is the new base, and we'll come back over and suppress the first. And Sometimes it can be an advantage if we want to keep all of these mates that I just hide this, but if I'm doing mass properties or center of mass, then we got to be careful of what actually participates in those calculations. So if I do an insert component, existing part in assembly, my revision 2 is open. And because I drew that with the same origin in mind, it comes in fixed, but none of the mates are applied to it. And then we can look at things like the clearances. Was that a good idea? Do I need to go back and change that? Maybe make the adjustment to the counterbore on this side so that has some fit. Are we going to put in bearings as this turns and moves, and we start to look at the dynamics, how it goes through the motion? What is available to make adjustments, and if we're driving this as a motor, we really don't know the orientation that this is going to sit on in the final. So if there is a motor shaft or something that has to go in and lock to the driver pin, and then that turns everything else, or if the motion's being parted by the slider, those become part of the specifications. And then from this side, if we were to add, so I can right click and open the part, and if I were to add the configuration for, and I'm not naming these as parts because again this is a what if scenario. So if we do those as the tapped holes, then we can pick up the S key on the top face, and the easiest dealing with the whole wizard really is just to pre-select that face, but I did want to illustrate the 3D sketch, so maybe we need to take a look at that. And whole wizard, and I haven't pre-selected anything, we haven't told it where we're working, so I need a counter bore, and for the metric, for the M5, normal fit and through all. And then on the positions, if we go into the 3D sketch, which I do not recommend, but is certainly possible, is that will put you in place, and that is a binding head because that's the hex bolt, or the inch terminology. So we would want a socketed cap screw that would be able to fit in there and be a little bit easier to manage. So as long as I'm in that point tool, then we'll be able to that geometry, and I would want to switch to the hidden lines, and I can't quite see that one, so maybe we'll go to the bottom, Control 6, make sure I'm in the work area, and then I can pick up that existing geometry. Nope, I'm in the 3D sketch, so it's not going to be too happy with that. Alright, so the 2D sketch I'm good with. Let's try a temporary axis. So with temporary axis shown, I can select Control Select, and that one went fixed. So I lost the axis, and then we would want to make that coincident. All right, so the two that I need to see on the 3D sketch are on plane, which tells it where it's located, and then how it's positioned. All right, so maybe the advantage of the 3D sketch is I can just go around putting 5mm through holes everywhere, but really it's not not overly convenient to work with. So I would say stay with the 2D sketch wherever possible. If you see that 3D sketch, make sure you pick your planar face and locate it. Otherwise, we'll put the dimensions in, see if it clears, if it leaves any zero thickness geometry, so it just happens that it's the exact same size as the thickness of my part. So we need to look at the custom sizing, and if all I do is make, don't remember the head size, but if I was to make that 9.8 and leave 0.1 on each side, so 4 thousandths, that would allow it to complete, but through this section it's going to be really thin, so want to make sure to have those considerations. And we'll save it. I'll go ahead and turn off the center lines and save it once more. Go back into the slider, and since we're in this, we'll go ahead and rebuild. And the current, so maybe one of these is dowel pins and the other one is the tapped holes, and it is going to be only for this configuration, so I want to make sure that that's checked and then accept it. And it's going to tell me that it has rebuild errors because the holes, the 5mm holes that it was attached to, are no longer there. So we can suppress. So if I decide to go back, I can unsuppress. Oh, and those went to the mate references. So where are the, going to find the mates. Okay, we'll go that way. And so the concentric to that and that are active, and there that is active, and so the mate references are actually the ones with the issue. So let's go back and check that because let's see, we'll let that catch up. And under the properties, it is not suppressed in this configuration. So that would be one solution is to suppress it and rebuild it, and possibly put in another mate reference, because we could have multiple mate references, or in that group we would just have to go back and apply the mates for this group. So there are times where we want the mate references to be available across all of the configurations, and this is one of those instances where not so much. So in this case we would add the concentricity. Did not want to go tangent. Well, and all of these are available to move, so it's still picking up tangent. Interesting. Alright, not sure why I'm not getting my... Oh, the pins. Alright, well that makes sense. Let's go with... I thought I was selecting the cylinder through the bottom of the hole, so I had a perceptual issue. So the pin goes, now the part is lined up, but the pin isn't. So the positions, we'd have to go back through and add all the assemblies. So there is a plus and a minus here, but that's really not terrible to the overall function to be able to switch. And then mentioning the switch, if I go back to the default, that rebuilds, and the base slider is still present, so this one I would want to suppress out of the default and just have that there for the comparison. So again, options to tinker around with and be able to see different different combinations of the group.